Hello and welcome to this new TouchDesigner tutorial. In this tutorial we are going to see how to set up a scene using the bullet solver component and how to render it. We will see a little bit how physics dynamics works in TouchDesigner. We will use forces into the system. We will make use of the collisions happening into the system to generate MIDI notes in real time in Ableton Live according to the key hit by the sphere. And we will see many more stuff. So now I will show you an example of this. So first of all, I have this 2 slider, and with this 2 slider I can choose the position of my sphere, the ball. When I left click the button on my mouse, the ball is falling. And when I right click my button, the system starts again. Alright. And now when I press the Q key, I give some forces to my ball. As you notice also, like when the ball hits the keys, a sound is produced, and this sound is directly connected to the Ableton Live system. I have an acid bass on the MIDI as MIDI node here. So now I will give some forces to my sphere. So left click and then Q key. And the sounds are changing. Yeah. So now we are going to build this system. Hope you like it. So first of all, we need to delete all the operators on our desktop, TouchDesigner desktop. We delete the palette for the moment, we don't need it. We close the palette. Yeah, so let's start with the beginning. So we need a bullet solver component immediately here. Then we will need camera, light, and render. And yeah, in this way we already rendered our bullet solver system. Now we don't see that much going on because the camera is too close, but if we move the camera farther, we will start to see already like the floor, and then if we go even farther we also see the torus here. But let's place here at 5 again, and we go inside our bullet solver and we get rid of the actors inside. We need new actors, and we need like an actor that is gonna be our keys. We are gonna need an actor that is our ball, and we are gonna need an actor that is our room. I think that's all. So first of all, we have this message. This message means that there is nothing inside, there is no sops inside, so we have to create sops. So we can already name them. One is the room, one is the ball, and the other is the keyboard. Let's call it keyboard. All right, let's start with the ball. We just need a sphere, and yeah, the sphere, the sops needs to be displayed and rendered in order to be seen by the systems. And now the message, the error message, the warning messages disappeared, and we already see a sphere. All right, let's create now our room. So for the room we need a box. We need to render and display it, and then we need like to give some dimensions, and the dimensions are for this box, for the box I created, 2.16, 1.4, and 10. So now we have a room. So what happens here? Okay, now I explain you a thing, because I selected 10 as size of my room in the Z axis. Why I chose that basically? I chose that because I want that because the camera is at 5. So let's put the camera at 10. No, like if it's at 10, it's gonna be outside. Sorry. So if the camera is at 10, position 10, it's gonna look at the at the at the box from outside. But when I put it at 5, the camera like gets closer, closer, and closer until it's actually inside the box. And now what's happening is that the camera is inside the box, and then it can look what happened inside the box, right? Yeah, why do we need a box? We need a box because when we use like physics, most of the times we want to simulate the real world, and sometimes the balls, for example, or the objects, they fall, but we don't want that they fall like into a universe. We don't want to get them lost into the universe. We want them like falling onto, for example, a floor, or bouncing against the wall, and that's why we need basically a box, a room, and we need the camera inside the room to see what's happening inside that. Of course, now we also have to select some characteristics for our ball and for our room. So first of all, the room. The room is not a dynamic object, but it's static. So that means like when the the bullet solver it's starting is physical process inside, and most of the times they are affected, for example, by gravity. But yeah, we want the sphere affected by the gravity, so the sphere has to be a dynamic actor, but we don't want the room be affected by gravity, so we want the room stable into the space, so we need it as a static actor. Other thing, yeah, most of the times maybe we need like convex hull as actor, but in the case of the room we want it like a compound, because otherwise the sphere that bounces into the room is gonna disappear, or is gonna behave like weirdly. So we want the compound. Also, what we want to have is displaying the collision shape also for the sphere. And the last thing for the room, we want some properties. So here every actor has these properties, and for this simulation we want that the friction of all the actors is 0, and the restitution is different according to the object. In the case of the room, we want a restitution of 0.8. So, and the restitution is like how much energy is given back to the object that collides to the room, for example. All right, regarding the ball, we want to have a dynamic actor, want the convex hull here. We want as properties like a friction of 0 and a restitution of 0.85. So a little bit more bouncy when there is like a collision. Yeah, and that's all. And now we can create the keyboard. We need to create like a couple of keys. So first of all, I'm gonna create the main keys, the main key, and I'm gonna use always box for it. And I need like size of 0.1, 0.06, and then 1.04. Of course, this is already like I did these things before and I know this, so basically yeah, we're gonna have like something long, like a key of a keyboard. And then I add new. I can call this key basic. And now I want to create a line because I need to do an instance. So the line has to have like 7 points. And then I want that these 7 points, I copy these 7 points because I just don't want 7 keys, I want more. So I copy them twice. I use a translation of 1. And then we can already see that the points should be more now. Yeah. So we have 13 keys. Perfect. That's the amount that I want. And then I can create sop the chop, and I call it keyboard. Also, so at the moment we don't see anything, and just because we don't see anything because nothing is displayed. So now we want to display the key basic. If we do that, now we see the key basic here, but we want the instance of this object. So for the instance, what we need to do is basically going into our actor instance on, then we say look inside, look inside the component and check for the keyboard that was the sop to chop. And from the keyboard operator, look at the channel TX, TY, and TZ. And now we should pulse, and we should see, but we don't see anything. So we basically have to just select static and pulse, and then the instances appears. So let's go further. So the characteristic of our actor now, it's our actor is static, as we noticed. We need to display the collision shape, and then we need a restitution of 0 also for this. No, a friction of this 0, and a restitution of 1. Okay, so and now we need also a material, so that we add inside here. Fong. We need a material that is white. White color, we can call it color, and then we go here and we tell to our actor to look inside the component and check for the color material, and now they should be all white. Yeah, they are white. Good, so now we have our 3 actors. We need a little bit to define better here the sizes. So regarding the ball, we want actually that the ball is a little bit smaller, and we go in X form of the actor and we say that we want a size of 0.05. And also what we want, it's like position of the keyboard that is a little bit different in the space. So at the moment we see this, and let's translate the position of our keyboard a little bit more in the middle, see, -1, right, because it was outside the box, and a little bit lower, -0.6, good. And then we also want a rotation of a scale of 1.6, so that we have like bigger keys. All right, now we also want a different light, because it's a little bit dark inside the room. So the light that we want is 7, so a little bit closer. Then we want a little bit of rotation of this light, so we can actually close this and look at the full scene. So we want a rotation of this light of -14. And also we want a pivot moved of 6. Sorry, I deleted 6. And the light is changing now, and -16. And of course you can change whatever you want. Now of course you can place the light wherever you want. It's just yeah, these are the values that I found more interesting for my work. So but you're free of course of choosing the yeah, the values you want. So now that we have our scene prepared and rendered, now we have to basically before diving into the collision stuff and everything, first I want to add already like the controls. So the controls are basically a panel, because with the panel chop we can control the right click and the left click. Then we want 2 sliders, and I'm just pressing the tab key whenever I want to add a component or chop to be faster. Right, so we have 2 sliders. One is gonna control the TX position of the sphere, and the other one is gonna control the TY. Here I want to select just the right click and the left one, so that means left select, right select. I can even call them left click, right click. And here I can add the math for the TX and math for the TY. And the math for the TX is gonna be like, the range is gonna go from 0 to 1 for the slider, to a range of -95, 0.95. And now I'm gonna again split the screen, check if this is true actually, because I have my ball here and I need to control and translate. So let's see what happens if I map shortly this to the TX reference. So when I go at the end of this, it's 0.95 and the ball is inside. When I go on the left, it's still inside, so it's good mapped. And if I will do such a thing, for example, with the TY here, no? Now we see that at 0.5 the ball it's like up in the room, but if I go like at 1, it's gonna disappear. Okay, and at 0 it's in the middle of the room. So what we want actually is that when basically, let's try the values that I already had for my TY. So when it's 0, it's -0.3. And let's check it out actually. So we go at the end, yeah, and I want that here. because I don't want that under the keys or like right above the key, but I just want a little bit distant um, from the keys. And now I want basically that the ball disappear, like still stay in the room when at the slider it's at the ending point. So basically here I have a value of 0.6, and yeah, this is the value that I want to use for mapping basically my sphere. So I will give a 0.6 here. And so now we can see that when we go, now we can close this again, go back with U key, I press the P, so we can check the whole scene. And now I can check that when I move my slider up, it doesn't go out of the box and it doesn't go under the keys. So that's what I want. All right, so now I merge all this in a unique operator, and in this operator I can even rename this one, rename and rename. Could have done maybe after the merge, but yeah, so that I don't need two operators. But yeah, TX and TY, very good. And now I can rename my merge controls. So yep, so now to control the ball, what I need to do is just adding a container, give the same resolution of my render. It is like in this case like it's 1280 720. Then I tell to my container to look at the render one. So basically in the container I just told to look at what's happening inside the view of the render one. That's basically the render. So basically what the panel chop does is like looking at inside a specific component, and I will give the container. All right, and now if I activate the viewer flag here and I click in this container with the left click, I check that I can see that yeah, in the panel is activated. But if I click outside the container, this is not happening basically, and this is the same if I right click. So basically it just looks what the mouse is doing inside the container, because we gave to the panel to look inside this specific container. So, and we can call this container scene, and we can say yes to all, so that's still following the clicking. So, and also we want the two sliders. So basically if we go inside here and we say like to as the layout, we can tell no children, yeah, and we tell bottom top. Basically bottom to top we are gonna see the two sliders when we launch the program. We see the two sliders here in the corner, but we want that these two sliders are basically located a little bit in a different position, otherwise they overlap. So, and we know that the sliders are 100 pixels long and 20 pixels high. So we can just say to the TY to move a little bit of 100 pixels on the X axis. And now we have like the two sliders 1 and 2. We can give different colors in order to then understand who is controlling what. So, and basically we can choose the look. So the background color of the TX can be, for example, black, can be white border, and also I want that inside here, I want this, the slider, the color of the slider, for example, white here. All right. And same thing here, I go here, white for the look. Yeah, here I want a look that is different, so I want it white. But I want the background that is blue, for example. Or, yeah, this one. Yeah. And now I have two different colors, one for the TY and one for the TX. What we need to do now is like basically mapping. I want to map not these two mattes, but I want to map from control so that it's a little bit cleaner. So I again split the view, I go into my actor ball, press key, and then I map like the TX of the slider here and the TY of the slider on the TY axis. Now when I move the sliders, I can place the ball in the space wherever I want. And yeah, we need to establish what the left and right click are doing. So I want that when I press the left click, when I press the left button of my mouse, the system starts. And when I press the right click, the right button of my mouse, then the system will go into the starting position but will not start. So let's give an example. So I have to go into my scene container to do so. So when I press this and I press the left button, then my ball is falling. But when I right click, I stop everything and everything goes into the starting position. I can do it even in here so it's more visible. So I can basically choose the position, right, left, then I click my left, everything starts, okay, the system is working, pam, 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 and then I want to stop everything, and then I right click for stopping everything, and I want another position, and so on and so forth. So now that we also have this prepared, we can basically focus on the most interesting part, I will say, of the system. And now we are gonna grab a chop bullet solver and we drag our keyboard, or maybe we can just type keyboard. Yeah, sorry, because I moved the component. All right, so now here inside the bullet solver we have a lot of informations, no? Like the positions of the keys, the XY, the rotation, the scale, the velocity, and but basically this velocity is gonna be like 0 because it's a static object. As also we have like an actor ID, body ID, and a lot of informations. But actually what we want of all these informations is like not the translate, not the rotate, not the scale, not the velocities, but we want the collisions, okay? And then we want that these are related to the actor. Should not be a big difference if I choose bullet solver, actor, or word in this case, but it's better to be precise and go for the actor. So I press the actor, then I grab a select, so we can close the splitting view, and then we can concentrate and focus on this. So we grab a select, and in the select we just want the collisions happening. Now these informations are really interesting because if we see well, actually we should maybe do such a thing. We go back again into our, yeah, it's always like this with the bullets solver systems. We need like to go back and forth a lot of times, and so we grab the view. We don't need that big. don't need the big view of. So basically what I did is not launching the program, but I just want to see what's happening inside this component. That's basically what I see when I launch the program. Now I can again come back to my normal vision, and I press my left click. So what I see, it's like when there is a collision of my sphere with the keys, so with this actor, something is happening. And now we can even see something more interesting. So basically what's inside this actor, like what's inside this operator, it's not only the information about the collisions, but also an information about where these collisions are happening. So in this case, we can see it's like happening 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's 10. Yeah. So on the 10th key, and actually we have a collision here around the 11. Yeah, okay. And now it's moving. Yeah, the ball is moving, and we have a collision between the two. And now it's just on the 12th, on the 11th. On the 11th. All right. So this information is pretty helpful and useful. So we don't, because we also know where the collisions are happening. So basically we can call this channel collisions. And now we can press Alt L. We will get our palette. We will go into TouchDesigner Ableton and grab our TouchDesigner Ableton package. I already have like connected before my Ableton, so my TouchDesigner will not ask me to create a new song, but yeah, so I have here Ableton, and I want to use the grand piano for the moment effect on my MIDI. So I charge these, and the Ableton package, first of all, we need to do two things. Grab our Ableton MIDI component. Yeah, is this still searching for the grand piano? So we can delete all the other components that they are here. We don't need them. Very good. Also, we need an input here, because I want to do easy connections. So we're going to use some Python scripts. So in, then I add the null, and I connect my collisions. First, before connecting my collisions, maybe it's better to do such a thing, shuffle. And basically I want to transform all these informations in channels that are more visible. So I swap the channels and samples, and now I have basically this kind of information that is like colliding. Maybe I can even call this, instead of colliding, I can call them notes or keys, maybe. Key. So now I have key 1, key 0, key 1, 2, 3, 4, 5. When I start the collision, I see even better the collision happening for the key number 10, right? So perfect. Now I want this because I want to connect it inside my Ableton TouchDesigner Ableton package. And now it should be visible. Yes, the grand piano is visible. I press the pulse, and a connection between TouchDesigner and Ableton inside the MIDI slot here, it's created, so that when I press, when I have like this situation of creating notes, this is possible for TouchDesigner. If you want to see better how create notes. I did a few days ago a tutorial about that. It's how to send MIDI notes and also how to control like the pitch bend or the aftertouch effect with TouchDesigner and Ableton. But it's not the topic of this tutorial. But yeah, it's basically we're gonna make use of what we learned with that tutorial now. So basically what we want, it's like creating now a chop execute that, and I need the value change on. I want to also rename these as sound and then drag these into my chop execute, and then I want that all the channels are grabbed. All right, then what else I want to do is like delete all what I don't need. So I'm gonna use Sublime. So, and I opened my Sublime. So now with the Sublime, I can basically delete all what I don't need. And at the moment, I don't need this. So first of all, now we have to understand a little bit what we want to do. When there is a collision between the sphere and the keys, we want that a note is played by Ableton Live, and we also want a different sound for each note. Okay, we want a sound that increases basically when goes from 0 to 13. Okay, so to do so, first of all, we want to do like, I want the number of channels of my operator sound. So to do so, I need number of channels. I define the number of channels like an integer because I need integer. And then I want that this integer is read inside sound operator. Okay. And then I want that inside the sound operator, the number of channels are read. So in this way, I'm gonna have like this value that is 13, should be 3, 6, 9, 12, 12, 14. So 14 is the number of channels. And of course, if I add or I subtract a key, the number of channel will change. The number of channels will change, and also this number here, this value here will change. Okay, so now let's go inside our definition of define on value change. So, and we say for n in range between 0 and number of channels. So we want to say that n, it's a specific value that we will use, has to be between 0 and 14 basically, or our the number of our channels. Okay, if operator sound and then the channel or the value n equals 1, and now we are saying that, so if this n, like the value here is equals 1, so for example in this case the key 13, do something, no? Like if you find like one of these key that it's equals to 1, then do something, and I will tell what. So, and the thing is to do is like to send a MIDI note. So I'm gonna tell to Ableton MIDI 1 send note and 100. So with this other script, I say it like, so when you see that one of these, it's like 1, tell to Ableton MIDI component, the one responsible for sending note from TouchDesigner to Ableton Live, yeah, send a note. So basically, note is the command to send a real note, because we can also send an aftertouch, a pitch bend or something, but this is like the command to send the note. And then we say a note that is between 0 and the number of channels, so between 0 and 14, and this depends on which key is hit by the sphere. This is very important. And then we want the velocity of this note is 100, so it's fast, like played, like, okay. So, and now the script continues because we want this to be else. So if it's not, if the value is not equal to 1, and in the case of all the other key, we don't want any sound, so we have to say to the Ableton MIDI 1 to send a note that is n, but it's equal to 0. And this means like it's like so fast that basically it doesn't happen because it's 0. And this other script also allows us to basically tell to Ableton MIDI when you play a note that is, for example, N. So for example, in this case, that we lost our ball. So let's start again. So when it's playing this note 10, you go to 100. Now, but when you move to another key, then this key is gonna be 0, so the note shut, and then the other one will play. Okay, I think it's kind of clear. I hope it's clear. We still need the return button. We can just place it a little bit up. We don't need all this stuff up here. Now we define everything. So we Control S to save, and now we have the script. Let's try to see what happens. So there are errors, of course. So I think it's about the position of the return, right? Indentation error, it's usually about where is located what, and probably we need to put it here. Let's see. No. So important thing is like to send, yeah, to write to the right distance. So in this case is 1 tab here, 2 tabs here, 3 tabs, and so on and so forth. But yeah, what I did wrong, I think, should be this MIDI. It's the wrong message that I send. It's not send note, but it's send MIDI. Now should work. Let's see what happens. Okay, no error, but what happens now? So basically, and this is something that can happen quite often. So basically now, here we have in our script, we have this, and we have basically we have like that the notes that is sent, it's between 0 and 13, and this is actually a really low note in Ableton. So I usually use to be sure to play like the right notes, I go a little bit for higher values. Now I save this, and now I play again. Exactly, so now I'm playing the notes. And so basically you can also choose like another value here, for example, yeah, and now it's changing the notes because it's moving, and we can hear, yeah, that's another note. All right, so but for example we can go for 30 and 30, say, yeah, and we go for example for a lower sound, you know. So yeah, all right, so once we say this, yeah, very scary. All right, last thing I want to do, the last things I want to do is like creating some forces actually for the ball. So we will need a component impulse force, and we want to use a force that is like 1 and 0.6, so that this means like I will basically do it. Yeah, it's not connected, of course. So we need to actually say to the ball, to the setup page forces, to take this impulse force. And now we can press the pulse. Yeah. So what we say here is like use force 1. I'm gonna press this. All right. Stop it. So when I pulse this button, so apply to the ball the force, a force that is like 1 on the direction of x, so basically it will be pushed on the right, and 0.6 on the axis of y. So, and this means like push like a little bit the ball up whenever I pulse this button. And this work, of course, it doesn't work here because it's not started yet, the system, so it just works when I press the left. Alright, but I don't want to pulse on this button. I don't want to press with my I don't want to press with my mouse. So I create a shortcut here. So keyboard in, I choose the Q, just the Q. And what happens is when I press the Q on my keyboard, there is like a 1, there is a trigger. Okay, so basically I'm now gonna map this to the pulse force. Let's see what happens. So I start the system. And now I'm pressing, of course, the N. All right. So I want to change something in my bouncing. So, and usually if we go into the bullet solver page, we notice that, yeah, the gravitational acceleration is normally set as minus 9.8. That is the reality, no? But in this system, the ball is a little bit small. I changed some values, and I set this at 3. So the gravity is less affecting the fall of the ball. Let's see what happens. So it's a little bit slower. And now I press my Q. And of course I can change it, no? Like I can say like 6, give me 6, no? So it's gonna be faster. So let's see what happens. Perfect. So with this set, we just need to say the last thing. So we go again into the bullet solver, we go again into TouchDesigner Ableton package, and I want to show you something that can happen. So now we are using a piano. Yeah, we're going live. So we use a piano, and if we, oh sorry, so I have to stop the other one, otherwise there is a big mess. So stop this, yeah, great. So if we check, like it's very short actually as note, But if we go and grab like a rhythmical power or other, I like really a rhythmical power, yeah. But I will also show you other examples. So with a rhythmical power, the note is pretty long, and if we check what happens here, yeah. Yeah, so basically the notes will be played whenever there is a longer contact with between the ball and the keys. So to overcome this problem and play all the time a note, I create usually a trigger chop. I set basically all the attack to 0, the delay to 0, and the release to 0. But then I want a sustain level that is like 1, and I want a minimum of the sustain length that is 0.3. That means like whenever there is like the collision, you make the trigger. It has to be fast when when it starts, like and to go to the peak, that has to be like 1. It has to be like really fast when it's over, like the release, so the decay and the release has to go fast to 0. But I want when there is this contact, at least the 1 value, the sustain level, has to be 0.3 seconds, so that there is a consistent time for like TouchDesigner to send a note to Ableton Live, and Ableton Live will be able actually to see something to play this kind of note. So, and this has to be a little bit understood according to the kind of note we are playing to with. So basically in this case now I press. Yeah. Yeah, and this happens also, for example, I choose another one. It was like the bass, I guess. Yep, acid bass. Let's check what happens with and without the trigger. So let's see. We can see also that in this case we can be also like we need also a shorter minimum sustain length. Yeah, that's all for this tutorial. I hope you enjoyed. I hope you will have a lot of fun. It's like creating like really fun systems with music, physics. Now I will release other tutorials using the bullet solver component for creating other scenes, and also I'm planning to do other tutorials on how to use this sendMIDI function with TouchDesigner and Ableton. So, but for now, if you liked and enjoyed this tutorial, please subscribe, and yeah, see you to the next one.